Good morning all. Today's question. The crank and connecting rod of a theoretical steam engine are 0.5 meter and 2 meter respectively. 2 meter long respectively. The crank makes 180 rpm. The crank makes 180 rpm in the clockwise direction when it has turned 45 degrees from the inner dead center position. Determine 1. The velocity of the piston. 2. The angular velocity of the connecting rod. 3. The velocity of point E on the connecting rod. 1.5 meter from the gudgeon pin. Last question. Position and linear velocity of any point G on the connecting rod which has the least velocity relative to the crankshaft. Okay, that is the question. This is the space diagram. Here OB is the crank having length 0.5 meter and BP is the connecting rod having length 2 meter, and this is the piston. We know that the velocity of piston is always in the horizontal direction. First we have to draw the space diagram. Here first mark the point O, then draw a line which is having a length of 0.5 meter, which makes an angle of 45 degree with the horizontal direction. We can take any convenient scale to represent the 0.5 meter. Then draw a horizontal line passing through O. Then draw an arc having radius 2 meter from point B, and that horizontal line and that arc will intersect at point P. Then we can easily complete the space diagram. Then here given RPM, rotations per minute, RPM of the crank OB is equal to 180, or the speed of OB is equal to 180 RPM, so that we can calculate the angular velocity of the connecting rod is equal to 2 pi n by 60, and that is equal to 2 pi into 180 by 60, that's equal to 18.852 radian per second. 18.852 radian per second, that is the angular velocity of the connecting rod. Next, we have to find out the velocity of B, point B, with respect to this fixed point O or crank center. Then that velocity is equal to velocity of B with respect to O is a relative velocity of B with respect to O, and that relative velocity is an absolute velocity because that point O is at rest. So any velocity relative to the fixed velocity can be represented as absolute velocity. So that velocity of B with respect to O is equal to omega of BO into BO, angular velocity into R, omega into R, angular velocity into that length BO, that's equal to 18.852 into BO. BO is equal to 0.5 meter, and that's equal to 9.426 meter per second. 9.426 meter per second. 9.426 meter per second. This 18.852 into this length BO. That's equal to 9.426 meter per second. That is the linear velocity of or relative velocity of B with respect to O. We can represent this one as absolute velocity of B because that point is at rest. That point O is at rest. Okay, next we have to draw the velocity diagram of this particular slider kind mechanism. First, fixed points. Here fixed point is O. Fixed point is O. And first represent this fixed point O. We can use small letters to represent the velocity diagram and capital letters to represent the space diagram. First, small letter O, fixed point. Next, velocity of B. Velocity of B with respect to O is always perpendicular to link BO. Velocity of B with respect to O is always perpendicular to link BO. And magnitude is equal to 9.426. So that we can take O here or mark O here. Then in a particular scale, we can choose any convenient scale to represent 9.426 meter per second. We can use 9.426 meter as 9.426 centimeter. Then the scale will become 1:100. Okay, we can use any convenient scale to represent the velocity diagram. First, fixed point O. Next, we have to draw the velocity vector of VBO having length 9.426 meter per second, and that must be perpendicular to this particular link BO. That must be perpendicular to that particular link, and this point will become small letter B. Then OB is the velocity of B with respect to O, and that must be perpendicular to BO. Okay, next, the velocity of piston with respect to this particular fixed link or the cylinder frame is always horizontal, because it is a constrained motion. The piston can only move in a horizontal direction, so that we can represent the direction of the velocity of piston as horizontal direction, or the velocity of P with respect to velocity of piston with respect to fixed link. This point O or this piston cover is both are fixed, so that we can represent that direction of P with respect to O or P with respect to any other fixed point must be horizontal, so that we can get this particular point small letter P here. We don't know the exact position of this point P, but we can find out this P by drawing the relative velocity of P with respect to B. The relative velocity of P with respect to B, relative velocity of P with respect to B is equal to angular velocity of this connecting rod, P with respect to B, into PB, omega into that radial distance, and that must be perpendicular to this particular link PB. That must be perpendicular to link PB and also passing through this point B. This point small letter B. That must be perpendicular to PB. Then we can easily draw a line perpendicular to that connecting rod and also passing through this point B. Then this intersecting point will become small letter P. That intersecting point will become small letter P. Then this OP is the velocity of P with respect to fixed link, or absolute velocity of P, or the velocity of the piston. And BP is the relative velocity of P with respect to B. This relative velocity of P with respect to B. Then this the head end of the vector must be here. Velocity of P, velocity of the head end with respect to tail end. The velocity of P with respect to B. Here again, this velocity vector head is like, we can represent like this. Then this will become velocity of P with respect to O. That's equal to absolute velocity, because that point O is at rest. Because that point O is at rest. Then we can easily find out this magnitude, and magnitude into scale. That will become the this length into scale must be equal to the magnitude of that velocity. Here again VPB is equal to some particular value. Then the answer will become answer VPB is equal to 6.8 meter per second, 6.8 meter per second, and VP velocity of piston is equal to 8.15 meter per second, 8.15 meter per second. And that is the answer. Then we have to find out the angular velocity of the connecting rod. Here angular velocity of the connecting rod is equal to omega PB, and that omega PB is equal to VPB divided by PB. VPB already found out, 6.8 meter per second, 6.8 meter per second, and that divided by PB. PB is equal to 2 meter. PB is equal to 2 meter. Then omega PB is equal to 3.4 radian per second. 3.4 radians per second. Radians per second, anti-clockwise. 3.4 radian per second, anti-clockwise. Next we have to find out the velocity of point E. Velocity of point E is at a distance of 1.5 meter away from the grid junction. That means that this point E is at a distance of 0.5 meter away from this point B. Then we have to find out the velocity of point E. Then we know that this space diagram and this velocity diagram both are similar triangle. Then the velocity of E with respect to P, or VEP, or small letter EP by BP, small letter BP must be equal to capital letter EP divided by capital letter BE. That means BE divided by BP, or BE divided by BP, that distance in space diagram, BE divided by BP, that ratio of distances in the space diagram must be equal to BE divided by BP in velocity diagram. Here point E must be on this particular line. We don't know that where is that point E lie. Where is that point E lie? Then that BE divided by BP must be equal to capital BE divided by BP. Then we have to find out that BE is equal to capital letter BE divided by capital letter BP into BP. Then we can easily find out that BE, and that point will be somewhere here, and we can mark this point E. Then by drawing this vector OE, we can find out the velocity of E. This will become velocity of E. Then velocity of E is equal to 8.5 meter per second. 8.5 meter per second. Velocity of E is equal to 8.5 meter per second. The next we have to find out the position and linear velocity of point G on this particular connecting rod, which has the least velocity. By analyzing this particular velocity diagram, we know that BE is greater than VE, and this VE or VP is greater than VE. Then for a least absolute velocity, that point point G, small letter G must be on this BP, and this distance, distance of that point G from O must be smallest one. For that smallest velocity, or for that minimum velocity, this particular line must be perpendicular to this BP. Then draw a line which is perpendicular to BP and passing through O. We can easily find out the least velocity point, small letter G. Then BG divided by BP, then BG divided by BP, small letter BG divided by BP is equal to capital letter BG divided by BP. Then, from this velocity diagram, we can find out the small letter BG, capital letter B, small letter BP already found out, and BG, capital BG, we have to find out that BG, capital BG, point or distance of that point, least velocity point from the point B. And that BG is equal to 1.47 meter. 1.47 meter. We can easily calculate that BG. That BG is equal to 1.47 meter. And this velocity of G, least velocity point on the connecting rod, VG. And that velocity VG is equal to, by measuring this particular vector length, then we can calculate this VG. VG is equal to this length into scale. And that VG is equal to 8 meter per second. This VG is equal to 8 meter per second. We can find out that velocity or least velocity point on the connecting rod with respect to this some fixed point, or absolute velocity of least velocity point G is equal to 8 meter per second, and the position is equal to 1.47 meter away from B. 1.47 meter away from B and lying on the connecting rod. And that is the final answer. Okay, thank you all.